And when we talk about the another heading as called power of a lens. What is called power of a lens? This power of a lens is defined as P is inversely proportional to R 1 by F, or F is called the focal length of the lens, or we call this a phi may be taken as 100 by F centimeter or 1 meter by F. So power is nothing but the reciprocal, and SI unit of power is nothing but diopter, and always represented by the capital D, and according to Cartesian sign convention, this D value may be plus or minus will be there. So when we talk about Cartesian sign convention, I am going to introduce where we will use the U is positive or negative, when V will be positive or negative, when F will be positive or negative in the case of that one. Suppose we take for a convex lens. Apply the sign convention, and this is the left side and this is the right side, and this will be taken as minus and this will be taken. So F1 to be taken as minus and here F2 to be taken as plus. And when we talk about above the principal axis treated as positive, below the principal axis treated as negative. So this is the case whenever any ray going towards, or we can say convex lens, V and F always positive. The image portion as well as the focal length is always positive in the case of convex lens. So in the case of concave mirror, what will happen? U, V and F always negative, because it is coming back on the same portion. So this is the way we are applying the sign convention, where U is negative, V is, but in the case of concave lens, and U is negative, but at the same time V and negative, F also negative as for the concave, because the concave lens produces only virtual image. So the power of a lens can be classified according to the position of the object when we are using the short sight and long sight, or hypermetropia, which is the disease of the eye, and doctor will prescribe. We will do some problem based on that. We are able to understand how the doctor prescribing the power for the small children nowadays wearing the specs because of seeing the television continuously or seeing the computer continuously, and this is a problem existing in our everywhere. So that is the reason how the doctor is prescribing this power. We will calculate by doing one problem. So this is the problem we are going to discuss. Number one, a doctor advises a patient to use spectacles with a convex lens of focal length 40 cm in contact with a concave lens focal length 25 centimeter. And what is the power of this combination? So whenever you are converging or you are taking the two lenses, that we call as a bifocal lens, and there is a defect in our eye is called presbyopia, and this defect can be rectified by using the person or the patient is suffering with the long sight as well as the short sight. He is not able to see the objects nearby as well as the objects very long. That is the reason he is using the bifocal lens of the convex lens. But when we do the problem, they are not going to give is a plus f or minus 25 or minus 40 or plus 25. That we are going to apply the sign convention. Then only we are able to understand how to do the problem. As far the first case is concerned, convex lens. I already told convex lens V and F is always positive. That 40 centimeter to be taken as plus 40 centimeter. And when we talk about concave lens or F2 to be taken as minus 25 centimeter, that is very important. So when you are reading the problem, they will not give it is plus or this minus. We have to come to the conclusion we are using concave lens and F is positive or negative. Here F is negative as per the F1 is concerned. And we will apply the formula for 1 by F is equal to 1 by F1 plus 1 by F2. It is a combination to get the, what is the final question they are asking? What is the power of the combination? So they have to calculate 1 by F is equal to or 1 by 40, substitute the value, minus 1 by 25 or nothing but 5 minus 8 divided by 200. It is nothing but algebra or mathematics, minus 3 by 100, 200, and finally we are getting P is equal to what is the formula? 1 by capital M, or we can say 100 by F in centimeter, or can we say minus 3 by 2, or when you divide minus 1.5 diameter. So this is the way the doctor will advise the patient. You can use the minus 1.5T. So there is the best option is available as per the entrance exam is concerned. We can pick the option B is the correct one by calculating in this way. So here there is a convex lens application, concave lens application, but here we have to select the Cartesian sign convention. Very, very important. Unless otherwise, if you don't know the sign convention, definitely this problem we can't proceed. So we have to know, we have to do the sign convention correctly and apply this formula. Finally, we are getting minus 1.5D is the best answer, or 1.5D diameter is the final solution for this problem. Let us go to the next problem to get more idea about sign convention. So let us go to the next problem. A 2 centimeter tall object. So the object height they are given as h. is placed 15 centimeter in front of a concave mirror. So our focal length they are given 10 centimeter. So what is the size and nature of the image? And they are given some options we can pick out by without doing the problem correctly. Suppose we will understand, we draw a concave mirror like this. And here it is the pole of the mirror, this is the F and 2F. And as far as this problem is concerned, they are given the focal length of the concave mirror is 10 centimeters. So this distance we can call it as a 10 centimeter. And 2F is nothing but 20 centimeters. But where we are keeping the object? But we are keeping the object in between, that is nothing but 15 centimeters. So when we keep the object between F and 2F, definitely we are getting the image real, inverted, and it will be increased, or we can say the image will be more than the height of the object. So when we are analyzing the options, so definitely it is a real inverted, so this will be ruled out. And here also none of this, and 1 centimeter real out of that one, we are getting the A is the best answer by coming to conclusion. Whenever we are keeping the object between F and 2F, we are getting real, inverted, and enlarged image or magnified image. When we compare this 4 centimeter, 2 is nothing but height and 4 is nothing but h dash. This is the way we are comparing, and we are selecting these options very fastly, quickly, but only things we should understand the position of the object where we are keeping. The same problem I can ask, I can modify, the object is between F and O. So definitely I can say the answer may be B. Virtual image, whenever you are keeping the object very close to mirror or very close to the lens, we are getting the virtual image, and we are getting 2 centimeter height of the object, but we are getting 4 centimeter. So the answer may be B as far the case is concerned when you are keeping the object between F and P. So in this way, we have to do the problem by reading, by understanding, number one, what is the length or what is the focal length of the mirror, what type of lens they are given, what type of mirror they are given. By analyzing the image, you are able to do the problem very fastly, quickly, by understanding the basic concepts. Let us do one more problem in this same application.